Hello viewers, welcome to this video lecture series on computer networks theory course. In this session I shall explain the different network models. What are network models and why do we require network models in order to make the communication happen between end devices. So let us check the details here in this session. Now before I start with the network model explanation, let me give you exactly the need for these network models. Suppose if you have two systems, let us assume that this is one device and this is another device. When you connect two devices in order to send the data, you call that as a network. Now most of the time what happens is this scene that the sender and the receiver makes use of the different operating system. Suppose let us take for example, if sender is making use of the Windows operating system and the receiver is making use of the Mac operating system, even though we have the different operating systems at the sender side and the receiver side and different system specifications and different network architectures present at both the systems, the data that is being sent from the sender to the receiver is possible because of the network models. So you can say in a simple sentence that network models helps in making the data transfer from the sender to the receiver. And there are two network models present. One is the OSI model and the another one is the TCP IP network model. So let us see the functionalities of these two models. Now the very first one is the open OSI model. OSI model stands for Open Systems Interconnection. So what is this OSI model consist of? It consists of 7-layer architecture, and in each layer has got some specific function to perform, and this was developed in 1984 by the International Organization for Standardization. So this statement you just see, to transfer data or information from one device to another, all the 7 layers work collaboratively. These devices are connected over the internet. This is what I just explained to you. To make the data or information transfer from one system to another system, network models helps us. Now, as I told just now, there are 7 layers in the OSI model. So these 7 layers are present at the sender side and they are present at the receiver side. Sender side, if you can see, or normally the data starts from the application layer, then it moves to the next presentation layer, session layer, transport layer, network layer, data link layer, and physical layer. Then if you see at the receiver side also, you are having the 7 layers, but the functionality starts from the physical layer, then data link layer, network, transport, session, presentation, and application layer. Normally these first 3 layers, okay, application, presentation, and session layer, we call it as the software layers, and transport layer is the heart of the OSI model. The network layer, the data link layer, and the physical layer, these 3 layers are the hardware layers. Now the topmost layer that is there at the sender side, if you see, the top layer will be the application layer. I mean to say, with respect to the functionality, the application layer starts functioning first at the sender side. These things you have to remember well. At the sender side, the application layer starts functioning first, whereas at the receiver side, the physical layer starts functioning first. So let us see the different functions that are carried out by these layers. The very first one is the application layer. Here the user directly uses the application software. So what is this application software? The applications that are used by the users are the browsers. Normally we make use of the browsers in our system, the Microsoft Office. There are so many social apps, gaming apps, emails. All these applications are carried out by the user. These applications are possible with the help of the application layer protocols. Now which are the different protocols that are present in the application layer? So here when we say normally the different layers, what are these layers consist of? Each layer is having a set of protocol. In simple words, you can always remember like this: each layer is having a set of protocols in order to carry out the functionality for that layer. In the application layer, you will find these protocols. For example, I have listed here few protocols. FTP is used for the file transfer. HTTP, whenever you are browsing on the internet, searching a particular website, the HTTP, or you have a secure protocol also, HTTPS, secured HTTP protocol. Email handling is done by the SMTP and POP3 protocols. Remote login, telnet comes into picture, and for network management, SNMP. So these are the few protocols which I have listed here that are present in the application layer. So there are so many other protocols also which will help the users in carrying out various applications. Next comes the presentation layer. So whatever I am discussing now is, let me explain you the functionality from the sender side. So sender side you have now just seen up till application layer. The next one is what? The presentation layer. Now what is the functionality of the presentation layer? Presentation layer functionality you can always categorize into three different functions. One is the translation, the other one is the data compression, the third one is the encryption and decryption. First thing is translation. User is using the application layer. So from the application layer, the message will be what? Moved to the presentation layer. This message, whatever is moved from the application layer to the presentation layer, is in the ASCII format, but the machines do not understand the ASCII format. So that will be converted into a form which is understood by the machine. So now the presentation layer convert the ASCII to EBCDIC form. The characters or the numbers which the user sends from the application, the presentation layer converts this character in a form understood at the recipient machine. Next one is the data compression. This is the second functionality carried out by the presentation layer. Normally, if the data that is being sent from the sender is huge, if the data sent from the receiver is 4 MB, the presentation layer can compress that and convert it into 1 MB and send towards the receiver side. So this will definitely what reduces the number of bits that are needed to be transmitted over the internet. And specifically this type of data compression we carry out for the image files, audio files and the video files. Then we have the encryption and the decryption. Now we have to maintain the integrity of the data. When the sender, when the data is sent from the sender to the receiver, fine, it travels over the internet and we want to maintain the integrity of that data. For that reason, we require encryption. So the data is encrypted at the sender side and it is decrypted at the receiver side. What do you mean by encryption? It is a process of converting the sender transmitted data into another form. And for that SSL protocol is used. Now where we are, so the data has come from the application layer to the presentation layer. The presentation layer has carried out its job. Now the data is moving from the presentation layer to the session layer. So what are the functions of the session layer? That you need to check. The functions that are carried out at the session layer is, first one is the session management, then authentication and authorization. Normally these three functions are very much required because see, these three are very much required to start the flow of the data from the sender to the receiver. Before the data is sent, a session has to get established between the sender and the receiver. So this is the job of the session layer. And in order to not only just establish the session layer will establish and it will make use of that session and also it will terminate the session. So these things are carried out by using the protocols NET, BIOS and PPTP protocols. These protocols are used here in the session management. The server will check whether the user that is getting logged in is an authenticated user or not. So this is the second functionality of the session layer. It will ask the user to type the username and the password. Fine. If these are found correct, then the connection between the client and the server is established. So this is your client and this is the server. In order to make this client get access to the server, the client has to first carry out the authentication process, wherein the client will type the username and the password, and if that is correct, then the client and the server will have the session established. Just getting the access to the server is not enough. The client should be able to access the files that are present in the server. The client should be able to download the files, because there are so many files which are not being allowed by the client to download. What privileges are given to specific clients, only those clients will be able to use those privileges in order to download those files. So that is what is the third functionality, authorization. It will give permission to access specific files or resources. This is about the session layer. Now you are here, the session layer has carried out its job. The data will move to the transport layer. And in the transport layer will carry out its functionalities. First one is the segmentation, second one is the flow control, third one is the error control. Now in segmentation, what exactly happens is, whatever data comes from the presentation layer, transport layer, what it does is, it divides that particular data into segments. So it will give the names to all the different parts of the data, segment 1, segment 2, like this. It will divide the data into segments and it will give the name to the segment. And to this segment is a source port number and a destination port number is included, as well the sequence number and the data unit. So the complete segment consists of It consists of the source port number, the destination port number and the data that has come from the application layer and the sequence number. So I'll just write it in a bigger font size. Source port number, destination port number, sequence number and the data. These 4 components together, you have to call it as segment. So this is what for we are using the source port number and the destination port number. This source port number and destination port number is related to the application. See, now the sender is from the sender side, the sender is using one particular application, okay, and for that application what is the port number? Because the source port number and the destination port number will make what the data reach to the correct application. Now at the receiver side also you are having the various applications. One is the browser, social app, email. Each of this application process you have the port number. So destination port number will make the data reach to the correct application. Is it the browser or is it the social app or is it the email? The sequence number indicates the sequence of the segments, and finally this is the most important. This is what the data that has come all the way from the application layer. Now this data is what encapsulated with the source port number and the destination port number at the transport layer. Now we have the flow control also and error control. Even these 2 functionalities are carried out at the flow control and error control. Suppose if this is the server and this is the client wants to download a file. The server is sending the data at a speed of, let us take for example 30 Mbps, but the client is able to process only with the speed of 10 Mbps. So in this case the client will inform the sender to slow down the sending of the data, to slow down the rate at which the data is sent from the server side. So this is one thing. Sometimes what will happen is the server may be sending the data at a rate of 5 Mbps, but the client is able to process still more faster, 10 Mbps. Even in that situation, the client may inform the server to increase the data flow rate for its performance. It controls the amount of data being transferred between server and other connected devices. Error control is also one of the major important functionality of the transport layer. Here in error control, what happens is, suppose if the server is sending data 1, data 2, data 3 like this over the internet, maybe one data unit is lost, then the server will resend that data unit request with the help of ARQ. The data that is lost in the internet, the client has not received the data unit, the server will retransmit that data. And the different protocols that are used here at the transport layer, TCP, UDP and SCTP. The most popular protocols are the TCP and the UDP, transmission control protocol and the user datagram protocol. The next layer in the OSI model is the network layer. Now the data has come from the transport layer to the network layer. So what are the different functions that are being carried out at the network layer? There are 3 major functions carried out at the network layer. The first one is the logical addressing. The second one is the routing, path determination. First one is the logical addressing. What we are carrying out exactly is the transfer of the data between 2 devices or 2 machines or 2 nodes. So this device, the sender one, will have a unique address called as the IP address. The receiver will have a unique address called as the IP address. So I can say that IP1 is the address of the sender and IP2 is the address of the receiver. So if these are the unique addresses, so these 2 addresses has to be included in the segment that is being sent from the transport layer. So now I can show you with the help of this diagram. This is the segment that was received by the transport layer. The network layer, what it will do is it will add IP address of the sender and IP address of the receiver, or you can say IP address of the source. I'll write it as IS, IP address of the destination. So, and the moment you add IP addresses, this particular thing becomes a packet. Now you have to call it the data unit as packet in the network layer. So here I have written the network layer assigns IP addresses of the sender and the receiver to form a packet. The next important functionality is the routing. Routing, why we require here is these devices to whom you are sending the data may be present in different networks. Here for example, I have taken one device is present in the network 2, this device is present in the network 3, this device is present in the sender, the one which wants to send the data is present where? In the network 1. The network 1 IP address is this one. So the network 2 IP address is this, and the network 3 IP address is this one. Now whenever the packet starts from the sender side, the intermediate device, the router, it has to decide the packet whether to send to this particular network 2 or network 3. So this is the job of the network layer only. So once the packet starts from the sender and the IP packet is having, let us take for example the destination IP address as 3.15. okay, this is the destination IP address. The sender wants to send a message and the destination IP address is 192.168.3.15. These first 3 octets, 192, 168 and 1, okay, the first 3 octets always decide what? The network address. Now the router can decide the route here because there is one network with 2.1 and another network with 3.1. What is the destination packet address? It is 3.15. So 3.15 is present where? Is present in this network 3 only. So it has to send the packet to network 3. So this way the routing functionality is carried out at the network layer. It decides to which network the particular packet has to be sent. We call that function as routing. It is a method to send the data to the correct destination using the logical address. The third functionality at the network layer is the path determination. Now the sender is present here, okay, in one network, and the receiver is present in the other network. There are various paths to reach the network. There is one path here, okay, the sender can choose this path or the sender can choose this path in order to send the packet. So selecting a particular path to make the packet reach the destination host is path determination. So, and there are various algorithms to select a particular path. Now at present in this topic, you just try to know what do you mean by path determination. It is the best possible path for the data delivery from the source to the destination. And there are various protocols, OSPF, border gateway protocol. The sixth layer is what? The data link layer. Now that the packet, I'll show you the initial diagram. Now where you are exactly, the message has come from the application layer, presentation layer, then it has gone to the session layer, and from the session layer it is sent to the transport layer. The transport layer has sent to the network layer. The network layer has carried out its functionality and it is now reaching to the data link layer. Now here you are in the data link layer. So what is the function that is carried out at the data link layer? Before you understand the functions that are carried out at the data link layer, you should know that there are two types of addressing. One is the logical addressing and another is the physical addressing. This logical addressing, as I explained just now, it is carried out at the network layer. The physical addressing is carried out at the data link layer. So physical addressing, how to find out? For your system, for your machine, for your device, on the network interface card is printed one address, and that address is called as the physical address or the MAC address. This MAC address is a 12-digit alphanumeric number. It is embedded in the network interface card of your computer. The data link layer will include the MAC address of the receiver, okay, that is the destination host, and the MAC address of the sender, that is the source host. So these two addresses will also get included. Now look here, earlier you were having what? Only the segment. Fine. Network layer added what? The IP address of the destination and IP address of the source. The data link layer will include the MAC address of the destination device and the MAC address of the source device. So now once these two MAC addresses get added, the data unit, you have to call it as frame now. Fine. So you started calling right from segment. First at the application layer you call it as a message, then comes what? The segment, then at the network layer you are calling it as a packet, and now finally at the data link layer you are calling it as a frame. So this way the data units are now transferred from one layer to another layer. Now let us see the different functions that are carried out at the data link layer. Data link layer performs two basic functions. What are those? First thing is, it will allow the upper layers of the OSI model to access the transmission medium using the techniques like framing. I'll elaborate on this point. The transmission medium can be a copper wire, optical fiber, or air. The second important function is it controls how data is placed and received from the transmission medium using the techniques like media access control and error detection. So normally what you have to check here is in the data link layer, in simpler terms, you can always look into this manner. One is framing, that is adding the MAC address of the destination host and the source host. Second one is media access control, and the third one is error detection. So how it is done? So the different mediums that are used to connect the sender and the receiver. If this is the sender and if this is the receiver, normally we can say that these can be connected by a physical medium, okay, using the copper cable, or it can be connected using the optical fiber, or it can be connected using what, the radio waves, that is the air. So if these are the three different transmission mediums, then the data link layer is responsible to make all the higher layers to access this medium, because the medium can be what, it can be a LAN cable, it can be an optical fiber, it can be an air. And normally when you are trying to send data to other devices in the internet, if you are having suppose multiple devices in the computer network, let us take for example some 4-5 nodes, okay, need not be that all the 5 nodes that are connected in the internet will be always using the LAN cable, or always all the devices are connected using the optical fiber. Sometimes one node with the other node can be connected with an optical fiber, or the second node with the third node can be connected with a LAN cable, or this can be connected with a radio wave. So there are different possibilities that all these devices that are used in the network, they may be connected using the different transmission medium. So it is the job of the data link layer to see that this transmission medium is accessible by the upper layers to send the data. And moreover, now you have to see that since the data is traveling over the internet from the sender to the receiver, to check the errors, to data link layer adds bits at the end of the frame, okay. If this is the frame, at the end of the frame there are certain bits. So these things you will be learning in detail in future topics when I teach the error detection methods. So these bits are added here at the end of the frame to check the errors during the transmission. Now these errors are occurring because there are certain limitations of the transmission medium that are used to transfer the data. So now the summary is that the data link layer is responsible for framing, media access and error detection. Now your data unit is here, okay, at the data link layer. Now it is moving to the next physical layer. What the physical layer, to understand, I have started writing this data unit once again here. This is the segment, okay, at the transport layer. Then came what, the data got encapsulated with the destination IP address and the source IP address by the network layer. And next the data link layer added the source MAC address and the destination MAC address. We call that as frame now. Next, in the physical layer, these frame, whatever are the contents of the frame, are converted into zeros and ones, and you call that as bits. So these bits are finally getting converted into electrical signal if the transmission medium is a copper cable, or it can be converted into the light signal if the transmission medium is an optical fiber, or it can be converted into radio waves if the transmission medium is air. So this is what I am trying to show here in the physical layer. Look here, the data link layer, the frame has, okay, is getting converted into bits here, zeros and ones. And in order to make these bits, how these bits are getting moved from the source to the destination, if this is the source and if this is the destination. So these are the bits that are getting transferred from the source to the destination, but these bits definitely will get converted into either electrical signal or light signals or radio signal, depending on how these two devices are getting connected. By what transmission medium are these two devices getting connected? Is it a copper cable, or is it an optical fiber, or is it an air? So based on the transmission medium, the signals get moved from the source to the destination. The signal generated at the physical layer depends on the type of the medium used to connect the two devices. This is what I told just now. Now what happens at the receiver? At the receiver side, the receiver will what? It will first convert the bits and pass it into the data link layer as a frame. Now the reverse process will start happening at the receiver side. So now you are here. So the bits got traveled and it is now moving to the receiver side. At the receiver side, this is the physical layer first. This will perform its function. It will convert those bits and it will send the data unit as a frame to the data link layer. The data link layer will decapsulate, that means it will remove the MAC addresses and it will send it to the network layer. The network layer will decapsulate, that means it will remove the headers, the destination IP address and the source IP address, and send the data unit as a segment to the transport layer. The transport layer decapsulates the port addresses, source port address and the IP port address, and sends to the session layer. The session layer will send that data unit to the presentation layer. Finally, because now whatever data received is in the encrypted form, the presentation layer will try to decrypt that and it will send to the application layer. Finally, the message is visible on the receiver's screen for that particular application. So this is how it is happening. All encapsulation part is carried out at the sender side and the decapsulation is carried out at the receiver side. So the message which was there here, how are you, which was sent from the sender, now it is visible on the receiver's screen. OSI model in this way will help to transfer the data between different hosts. These 7 layers are actually responsible for the smooth functioning of the internet. So this is all about the OSI model. Hope you find this session useful. If you find it useful, please like, share and subscribe to my channel. Thank you. Bye bye and take care.